All right. So hello, everybody. Welcome so much to our webinar. My name is Laurel Glenn, and I am the program manager for the safety project here. We appreciate you joining the webinar on the today, and we have all come to the meeting muted. So we would appreciate if you stayed muted till the question and answer session. Right now, the captions are going to be on for your convenience. The videos for everybody will be off for the time being. That's just in order to make sure that we have enough bandwidth strength for during the presentation. If you have any questions during the webinar, please type them in the chat box, which is down below, and they will be addressed at the end of this webinar. So the webinar today is Connected Vehicle Information for improving safety related to unknown or inadequate truck parking. And we have three researchers with us today. We have Brittney Gick. She is an assistant research scientist at Texas A&M Transportation Institute. And she has over 10 years of experience in transportation research at the federal, state, and metropolitan levels. Throughout her professional career, her primary research areas have been pavements, freight, metropolitan planning, and emerging technologies, such as automated vehicles and electric buses. Beforehand, she was an associate program officer at the Transportation Research Board, where she supported standing committees on policy, freight, rail, and marine issues. And in addition, she maintains a Class B commercial driver's license. You'll also meet today Nicole Katsikides. She's a research scientist at Texas A&M Transportation Institute as well. And she's also adjunct faculty for Community College of Baltimore County, teaching domestic and global freight courses. She advises on freight, supply chain, and logistic issues, and has 22 years of public sector experience in transportation planning and policy analysis, logistics, economic development, and land use or real estate planning with specific expertise in freight mobility and operations. She holds a PhD from the University of Maryland, Baltimore County, a master's degree in policy analysis from Johns Hopkins, and a bachelor's from the University of Notre Dame, Maryland. And we also have Stephen Bell with us today. He's a senior research specialist in the Demonstration and Deployment Research Group at the Virginia Tech Transportation Institute, Division of Freight, Transit, and Heavy Vehicle Safety. Stephen's research has focused on the utilization of GIS applications, including hotspot analysis of wildlife vehicle conflicts in Virginia for the state's Wildlife Corridor Action Plan, analysis of the viability of curbside loading zones in urban areas, and land suitability modeling for truck parking opportunities in a given area, such as today. Prior work experience is also with daily public transit operations, route map making, and management of automated data collection. So the three of them are going to be presenting the topic today. And right now, I'm just going to go ahead and turn things over to Brittney for our presentation.
Thank you, Laurel, and thank you to everyone for attending today's webinar. First, I'd like to start off by recognizing our entire project team. From TTI, along with Nicole and myself, we have Smriti Parab, William Huang, Dai Li, Jose Rivera, Reza Farzana, Jack Kong, Tat Srisan, Jeff Warner, and David Schrank. Along with Stephen from BTI, we also had support from Andy Alden. Safety issues due to inadequate truck parking are a national concern. The lack of safe and legal truck parking can lead to truck drivers to drive fatigued and park in unsafe locations, such as along ramps and shoulders. When truck drivers do not have reliable information about the availability of parking, this further exacerbates the problem. The purpose of this study was to derive insights that can help state DOTs and other transportation agencies to understand the inadequate truck parking. We use big data to understand where trucks are parking, and then other data sources to evaluate supply for new truck parking opportunities. But we also wanted to look at ways that we could disseminate truck parking information to drivers. The purpose of this project is to evaluate big data to determine if the historical data can be used to notify truck drivers about the likelihood of available truck parking ahead. This project takes an applied approach. It may not be perfect, but it is a start and one that is desperately needed. DOTs need an approach now that can alleviate truck parking problems, and drivers also need the information about where truck parking is available. I wanted to share a few key findings from our knowledge synthesis. So one aspect was driver safety. Many truck parking studies cite concerns about safety related to truck parking, but a lot of the research related to safety is anecdotal in nature. Drivers do feel that inadequate truck parking puts them at greater risk for personal injury or theft. There are issues with unofficial and unauthorized parking, even when official parking is available, because drivers may perceive that parking is not available at the lots, or their lots are busy. Maybe that place isn't a good fit for them, or it's inconvenient. Fatigue drivers is another concern. And if there's unavailable parking, then this can lead to drivers continuing to drive to look for a good place to park. Hours of service violations are another concern. If they cannot find parking, then they may have to park in an unauthorized or unsafe location. More research is needed to evaluate how truck parking scarcity contributes to safety issues such as crashes. We've also found in many studies that truck drivers are hesitant to use weigh stations. Next, I'm going to go ahead and turn it over to Nicole to discuss our demand data.
Hello, everyone. For this study, we really wanted to try to come at it from the perspective of a DOT. And a lot of DOTs have truck probe data that they use for congestion analysis and different things that they might be doing, like travel forecasting or project assessments. So we worked with the Maryland Department of Transportation, State Highway Administration, who was gracious to allow us to use some of their truck probe data. And in this case, it was INRIX trips, their access to the INRIX trips data set, which they've had for a number of years. And they use for lots of different things. And we wanted to see if there was value that we could squeeze from it that would help them also to understand truck parking in a more robust way. So this was all about trying to use something that the DOT already has and not trying to make it foreign or something that they'd have to pay a lot for in order to be able to do it to understand truck parking. So the INRIX trips data set, we used a sample from March 2019. We also used heavy duty vehicle crash data from Maryland State Highway from 2019 to 2021. And we limited this study just for this purpose to Howard County. And if you're not familiar with that area, I-95 is obviously a huge major freight corridor, and Howard County is just north of Washington, D.C. It's a very busy area, and it's also home to crossroads of a lot of freight infrastructure and many warehouse and distribution, sorry, I can't get that out, that serves not only areas to the north, as far north as New York, but also to the south. I do want to say one thing about the INRIX trips data, and that is that one thing that Maryland has used it a lot or likes about it, and that we've seen in our work, is that you can look at different weight classes, medium duty and heavy duty, as well as light duty. So you're able to look at things in different ways, which offers some more intel in what we're trying to do. Next slide. So we did a couple of things in order. The first thing we wanted to do with this work is to understand where trucks are parking, where's the demand, where's the need, and how can we use data in a smart way to identify that and in a fairly easy way so a state DOT can replicate it easily. And also you'll hear later on about meshing that with supply and the value of it for the users of the system. I'm solely going to talk about estimating the demand at this time. So there were three basic ways that we try to get to demand or get some intel on demand. One is by applying some mathematical algorithms in artificial intelligence that are used for clustering. And so they are useful for taking big data sets and trying to identify locations of clusters. And so that's one element that we used in this work. The other is geohashing, which is help to take the data and identify the location of points within the data where you had clusters of parking. So we were trying to experiment with a couple of different ways to be able to quickly and easily identify those locations for parking. We could always throw things on a map, but what we were trying to do is come up with something that would be that you could run and that would be pretty reliable in terms of identifying those locations where you do have clusters. And why that's necessary is it can help as things change over time and you see some seasonal changes in freight flows, applying these types of methods. And I know I'm oversimplifying for the purpose of this webinar, but applying these types of methods can help to keep track of maybe how things are changing, because we're not just looking at where trucks are parking in particular lots designated for them, but also these clusters of activity of parking that we see. And we've noted that sometimes there's a cluster around the port. Maybe it's not in an actual parking location, but it's near a particular business. Maybe there's something on the Eastern Shore. We didn't look at the Eastern Shore, but in other work, we see things during growing seasons. So being able to run these algorithms or these geohashing helps to keep track of those things a little bit more easily than just looking at maps. And then we looked at testing the reliability of the information and and what it provides. Next slide. I won't get too deep into the algorithms here. If you're interested, I'd be happy to have an offline conversation with you. But the first thing in order to get to this was to filter and slice the data to ensure we had those stopped trips, the non-moving trips within the trips data set. Then we applied 3 different artificial intelligence algorithms that were built for trying to cluster locations. And of course, we evaluated the results and tried to replicate the process and evaluated that process as well. Next slide. For geohashing, this had a lot of steps. It certainly involved the use of ArcGIS to help us identify and geofence the area of interest. And just to kind of simplify this slide here, if you're interested, we can again talk offline, or there's more information in our report. But we applied a geohashing technique to the data in order to identify the locations and keep track of the locations. Geofencing, one thing I will say about it, it can help sometimes when anonymity, or you don't want to like reveal the exact location of something. So this helps to get to the area of clusters and helps in maybe some of the proprietary issues that are involved with using freight data. Next slide. Reliability. And admittedly, this is the one that I have been most involved with and know most about. So this one here we take the data, we geofence the area that we're interested in. We can look at official parking and unofficial parking by doing this geofencing. And so then we look at the points within the boundaries that we've created, as well as the unofficial parking boundaries. And we're able to extract those waypoints for trucks parked at the particular site. And then we can compare the number of trucks that are parked in the official parking area, as well as the trucks that are parked in the unofficial areas like ramps and shoulders. And so this particular technique, I should backtrack, isn't about identifying clusters. It's more about, does the information that we have tell a reliable story? And so in this case, we were looking at specific truck parking areas, doing the geofencing, identifying trucks parked in the spaces, as well as trucks parked on ramps and shoulders. Comparing that, sometimes we see that there's a lot of trucks on ramps and shoulders, but none in the actual lot. And so that tells us that's something we need to evaluate. What we were doing here, though, was looking at this information and trying to see if it was consistent over time. Because if it's consistent over time, it might be valuable information for truck drivers to know that year after year, this month, this time of week, this time of day, you're likely to find parking or you're unlikely to find parking. So that's what we were experimenting with here, was trying to see whether or not it painted a reliable story. This needs a lot more work and a lot more testing, but it was something that we felt was a good start to try to see how a state DOT might use this data in an even more value-added capacity. Next slide. So the key findings from the data assessment that we did, coverage, it's a sample. The data that we're using, whether you use INRIX or ATRI or something else, it's always going to be a sample. It's not going to be 100% of the trucks. And so you really have to think about and work with the data vendor to understand coverage and to assess what you're getting. We applied, we have been working for Maryland DOT a lot. And so we had been doing a lot of looking at AADT data. They have some very old manual accounts, but the AADT stuff is newer. We looked at some nearby way in motion data to try to ground truth this data in the past, but that is something that if you're working with this type of data, you will want to consider. Bias and characteristics. There's a lack of transparency with the different data methodologies among the data sources, which can sometimes lead to inconsistency. So different probe data sources are collected and put together differently. And it's important to understand what you're working with, how it was collected, the balance of trucks that are in there. Like I said, in this particular case, Maryland has the INRIX data, and we've seen robust medium duty as well as heavy duty trucks, but in some locations throughout the United States, maybe there's more medium duty than heavy duty. And that's something that you have to work when you're evaluating coverage to figure out. Oftentimes, truck probe data lack information about the vehicle, type of cabin, single unit versus combination. So if that kind of information was provided, if we could get more intel about the type of truck, that would certainly help, or even the commodity that they're carrying, that would definitely provide even more understanding of how the trucks are parking, why they might be clustering, or the usage at different lots. And that, I think, is a great study for next time. Sometimes too, there's cumbersome analytics. Processing big data can be cumbersome. It can be time consuming. It requires some data and analytics expertise that state DOTs may not always have in-house, but the things we tried to do here, we feel are not necessarily easy, but also don't require state DOTs to go and invest in a lot of resources, just some intel and expertise as to how to do it and to run the data on their machines. And I think that's the end of my section, so I will be passing it. Oh, I'm sorry, I have one more slide. Parking detection errors. Cameras and sensors sometimes don't always accurately detect vehicles in parking spaces. And while a lot of state DOTs are moving toward getting cameras and sensors, and that's fantastic, and that can provide more real-time information to the drivers, this data can help understand gaps or fill in blanks that state DOTs, and until state DOTs can roll out a robust, reliable system, maybe using this data can provide truck drivers something, and in the case of knowing where parking is available, I think something is better than nothing. One other thing to mention, inconsistent reporting, especially when it comes to safety. We looked a lot at the safety data in addition to where trucks were parking. And there are different standards in reporting for safety data among states, and that's something that's been happening for many years. So we don't always know that something occurred because of lack of parking or that it was truck involved. It might be coded differently. So that is something to keep in mind when you're looking at big data and evaluating truck parking. Also, with observational data, it's hard to do manual counts. It's also very expensive and it can be dangerous. So using truck probe data can certainly help alleviate that. You certainly need to ground truth and to have some indicator, or to try to maybe you don't have to do manual counts every year. In Maryland's case, they had done manual counts for a long time, but we're only getting manual counts from 2 days a year and 2 hours of each of those days to reflect truck parking counts for the whole year. So that's not very good either, but it was the best they had at the time. So using the data that they have available to them through the INRIX TRIPS data set, they can supplement those manual counts or do them in lieu of the manual counts for a couple of years and get pretty accurate information about the parking behaviors throughout the state. And also, there's no one perfect data set, so crowdsourced information isn't always accurate either. So there are some of the crowdsourced things like trucker path. That was used by MDOT in the past to try to understand usage of facilities, but it wasn't able to be snapped to the network. Somebody posted a question about the algorithms. It was Birch, DBScan, and Optics. Those were the three that we tested. Okay, next slide. All right, thank you. I'll pass it on to Stephen Bell.
Hi, everyone. Thanks for letting me get on, ask me to come on and speak on my part of this project. Hopefully my office mates don't make too much noise. One might lift their head or something. So we can go ahead and get to the next slide, please. Okay, yeah, so the main theme I kind of went for with this analysis, what we created was to keep it approachable. I think that was sort of on the demand side, we kind of talked about that a little bit as well, you know, using publicly available data sets, relatively straightforward GIS processes to analyze the data. Basically, this is just used to set the groundwork for a repeatable method anyone can recreate and then edit or change the variables, processes as they prefer to suit the needs of their analysis. Next slide, please. I'll get more into that information there. So here are the steps we created to find the usability of a land parcel. So, you know, choose the area you want to analyze, find relevant layers to analyze that data. Then we'll run what's called a suitability analysis, turning otherwise qualitative data into a quantifiable, useful value. We'll get more into that, but then the remaining steps require more qualitative data, or maybe rather it's better to say it's more like a subjective approach when considering other elements that may not be so easily quantifiable. Next slide. But so suitable land parcels, you know, what do we consider those? And so we categorize them in two ways, you know, either unutilized areas owned by a government agency that can be used to create parking areas, or by currently existing land, either owned publicly or privately, that is already flat paved area or something to the tune of that could be a currently existing parking opportunity. So we had our area to analyze. They did the demand side, and so now we're looking at the supply side for Howard County. And so the four data sets we sort of started with here and what we'll sort of build off of, we went with land ownership, two different land cover, land use layers that we sort of mingled just to make sure that what we're seeing on each sort of match with each other, and then elevation for a process we'll talk about later. Next slide, please. So now what we have to do is run what's called a suitability analysis. I can't take all the credit for deciding to use this analysis. Smriti, who was on the team, she mentioned it, and I sort of ran with it. It was a great way to sort of coalesce all of the data into one useful layer for us. But essentially, the shortest way to describe it is we're trying to provide a quantitative value to otherwise qualitative data and assign a weight to those layers with the value we give them. So for instance, if we're looking at the land cover, a tree cover in buildings would probably be considered a 1 because we can't really park trucks there, while paved surfaces are a 5, you know, on a scale of 1 to 5. And then residential agricultural land ownership layers, we'll probably give those a 1, while commercial and exempt land parcels will give a much higher value of 5. Then we assign a weight to each of those layers that we analyze. So land ownership and then land use land cover, I gave 40% each. And so you can see it's split into each 20% to the two land covers. One of those is from the MDOT GIS database, and the other one's from the Chesapeake Conservancy. If you aren't aware, they sort of mapped out a large area of the US in very, very high detail, looking at different surface types. And then we used terrain ruggedness. That was one of our last ones, sort of created from the elevation data. There's a calculation essentially that you run using elevation data to show the smoothness or ruggedness of an area. Next slide, please. And so essentially with the user's input, but where the user's input really matters here and can be adjusted for any other option they can think of. Then a couple more GIS processes help to refine this data into a usable layer for the analysis, what we're looking at here. But we use zonal statistics and then a spatial join with the land ownership layer. What you end up with is a map of the area we're looking at with an average score across the whole area for its level of suitability on a scale, again, of 1 to 5. You can go to the next slide, please, now. So yeah, from there, there's a lot we can do with that. This is intended as a baseline for finding opportunities. It can be refined in any way really you can think of to reduce those unsuitable layers from appearing higher in those lists. Because as we look through the list, there was some useful information there, but otherwise you would see small parcels that were flat, that were publicly owned, but there's not much in the way of parking areas. So as you go down the list of more and more refining, you can remove those outliers. Then you can add as many or as few different data layers as you want that can be quantifiable for this part of the analysis. You can even run more GIS processes available to the typical user. For instance, I believe next slide. Yeah, so what we're looking at here is drive time areas. This is another option for looking at availability in the area. So choosing an area in that cluster zone, you can kind of see to the bottom right there. This is one of the zones of clustering we were looking at. What we did here is essentially clicked a point along the highway on the interstate there on 95, and it generated 5, 10, and 15-minute drive time trade areas is what they're called in GIS as a way to determine, the distance it takes to get there. Because as we all know, that's probably a very important thing for a truck driver to know. You can go to the next slide. So yeah, here's another option for analysis. I'm sorry, it's a little difficult to see where Howard County is, but it's essentially right there in the center. The EPA's EJ screen is a really useful tool in looking at different methods of how you may want to refine an area and its usability. For instance, we're just looking here at demographics. Where in Howard County are there people in a higher percentile of seniors? And so it might be an area that you'd want to try and avoid. So next slide, please. So ultimately, as we're finalizing this list of potential parcels that are interesting to look at, we need to be manually determining where it is suitable for trucks to park. Manually meaning driving to these locations to confirm what the analysis found, speaking with private owners on potential options for parking in their area, speaking to the government agency, checking the access to water, sewer, security, lighting, et cetera. And the list goes on. From there, when we look at human or environmental receptors to make sure that we're not adversely affecting anything. So the final result of this was just a reduction in the scope of manual assessment needed by calculating each parcel's determined value in advance, thus reducing the overall effort in finding these locations. And I believe that's it. Yeah, so from there, my last little point here will just be that, if you want to look more into the GIS processes, if you're more of a map geek, kind of like I am, and like data, Appendix B in the report is going to be where my write-up is of the processes used in this analysis. Thank you.
Thank you, Stephen. Next up, we just wanted to share a little bit about our final output. So we decided that it would be helpful to have an online map that showed all of this. And Nicole, if you want to expand on that, I'll let you go ahead.
Sure. So in order to help people digest all of this information a little more easily, we turned it into an ArcGIS Online product that you can access. It's public. So there is the link, and the next slide has a picture of the map. So it's a little hard to describe it since it's static in this case, but if you want to play with the map, you're more than welcome. And you can turn on different layers. So all the things that I talked about, the geohashing layer and that information is there in terms of the demand side, and all the things that Stephen talked about are there for the supply side and our property evaluation. So you can see the areas of demand as well as, guess if, Brittney, would you mind dropping the link in the chat for me while I'm talking? You can see the demand on the map as well as the crashes. We did want to look at crash information in relation to into the demand, and then you have the different areas of opportunity reflected as well as the land ownership areas with average land suitability. So you can go into that map, turn things on and off. You can also bring in, if you're interested and want to play around with it a little bit more, you can even bring in other layers that provide even more context, Maryland DOT has a lot of different geospatial layers that we experimented with bringing in and bringing out, like land use and parcel data. And at the end of the day, the output of this, we feel, is that we can see very easily where the clusters of demand are, where the safety problems are, and where there's suitable opportunity to improve on parking. And then we can use some of the property information that Maryland has available to have discussions potentially with landowners or businesses that are in these areas, especially along the I-95 area where it says Laurel and BW Parkway, to see where there might be some auxiliary parking or optional parking opportunities. Next slide. So the next couple of slides are just examples in a little bit more detail. So here you can see this cluster. It has the algorithm-derived parking clusters, the high truck crash locations, the geohash-derived parking clusters, and then opportunities for parking. So this is parking. This is area 1 in Laurel around the Welcome Center. And the next slide. This is an area that is a little different. It is called West Friendship. It's out along I-70. And so we're able to see the locations of demand and also the particular areas that would be suitable for parking. Next slide. This one here, Waterloo and Jessup area, this is a major industrial area. There's also railroads nearby, so there's intermodal, lots of freight going on. We can see these clusters here using the data, the demand data, the crash data, and then the areas of opportunity. And so we've identified these areas outlined in this blue area in the screen. Well, particularly in this case, the blue one. So you can see that this is an area of focus that we should target on in order to identify some parking opportunities in this area. Next slide. And this is just another example, another area that we identified using all of this data together that helps to show where we should concentrate our efforts to look for additional parking. Next slide.
Great, thank you, Nicole. To gain insight about current truck parking detection processes and perspectives on information dissemination, we conducted several stakeholder interviews. These were completed in March and April of 2022 and included interviews with state DOT staff, technology providers, shipping companies, and truck drivers. So we shared our initial stages of this work in the interviews and received feedback on the processes. So I want to share a little bit about that. The stakeholder feedback supported the initial stages of this project. They seemed to like what we were doing and felt, especially from the state DOT perspective, that this would be something useful that they could implement. They did share that it is important for DOTs to be able to filter parcels based on land that they can control, such as right-of-way or available land that they can purchase. New truck parking opportunities need to be located in spaces that are convenient for both truck drivers and the critical freight network. It need to be in the right location, and that's why the suitability analysis helps, because they can identify those locations that can be the best for drivers and the network overall. Being able to get reliable information to drivers is a big part of this, and we heard this throughout the interviews in several cases that if the information is not accurate and reliable, then it's really not helping anyone. So it's important to make sure that we can get the correct information out there. We also wanted to get feedback on the best ways to disseminate information and the methods to do that. So some of the preferred applications among truck drivers, Trucker Path was overall the most used mobile app. They seem to really enjoy the app, and it is a crowdsource, so a lot of drivers that we spoke to seem to trust that a little bit better. They also believe that there needs to be one app that can be used in every state. It's not convenient for a truck driver to have to change methods of getting information at the state line. That's not an efficient or good use of time when they're already trying to get to their destination as quick as possible. There's also an issue with private truck stops that they're often unwilling to share information about how much parking is available at their location. And this can often be because they feel like they may not get those fuel or food sales, so they sometimes just are not as willing to share that information. Something that I personally thought was very interesting from our interviews was that the drivers we spoke with we're actually supportive of getting information from the electronic logging devices. This would definitely need to be a short message because it is in cab and it can't be a distracting tool, but there could be a way that if a truck driver gets the message on their ELD, then they can pull over and maybe access more information from a mobile app. There is also a risk because there are different ELD out there that this could lead to a risk of not all truck drivers getting the information that is needed. So we also talked about the current information technology systems that are out there, such as the messaging signs along the highway that indicate the number of spaces available at an upcoming parking facility. These systems do appear to be inconsistent from state to state. The state determines the threshold for what number of parking, or if it tells the actual number. The drivers we also spoke to said that these signs need to be within 5 miles of the parking facility. If they're further out than that, they tend to not trust that the information is accurate because trucks may have already taken those spots by the time they get there. Truck drivers prefer, in-cab messaging. That's the best way to get the information. Simple and minimal information is key. Things have to be quick. And then again, like I said, they can always pull over and access an app for more information on what may be available at that facility. The truck drivers that we did talk to were very adamant that they need to see the actual number of spaces available. They didn't always like the signs that showed a low number of parking, for example. This just led to more hesitancy that there would actually be something available when they got there. So having the number of spaces on that signage is critical so they can evaluate whether they can or cannot park when in that upcoming facility. So that kind of wraps up our presentation. Just to close out, this applied approach provides an opportunity for DOTs to utilize the data that they already have to understand where the need for parking exists and where the potential for new truck parking opportunities can be implemented as it relates to that need. While it may not be the perfect answer, it is a start, and where DOTs can address inadequate truck parking, which is a major concern across the country. And it can also provide safer and legal truck parking to drivers. At this time, we will go ahead and open it up for questions.
All right, if you do have a question, you can go ahead and unmute if you want to and ask the question, or raise your little hand in the little icon. I do have a question though. Is there any other kind of additional data that you've already identified that could be useful in order to find new truck parking opportunities in other areas?
I believe that's a question for me. Yeah, so I sort of mentioned it before, but yeah, there's many different layers out there that are probably very useful for this analysis. Again, we're just trying to provide that baseline here. and then work on that and add to that. A big part that I would probably say in there would be, equity is going to be a big one. It's very easy to just sort of place these where you think, lots of high traffic are occurring. You think it's going to be very, very well placed, but it could be adversely affecting vulnerable people in the area for whatever reason. So we just want to keep that in mind.
I'll go ahead and ask another one if there's no one right now. What would be the next step? So you kind of talked about, what the truckers would want to have in order to receive this messaging. So what would the next steps be so you can get this data out there for drivers to know about the availability of truck parking? And what would states need to really do to incorporate that information?
Nicole, do you want to take that one?
Sure. Yeah, I was looking at you, but I'm happy to start. And then I see Scott has a question. I think, we are scratching the surface with looking at this data to see if it can tell a reliable story. We only looked at a small snapshot in time. So I think more work needs to be done there to see if it's if it tells a reliable story about existing parking locations, and if it's responsible to put it out. As we were working with this, several of us on the team came up with questions like, well, what if we put it out and it's wrong? What's the liability? And I think that's one of the complexities of the whole truck parking discussion, is that this truck parking issue isn't easy to solve. And so there's a lot of criticism right now about why states aren't doing anything. States are actually doing a lot, but there's only a certain amount that they can do. Putting out this data, I think that needs to be a discussion, and I'd be interested in your all's feedback. Is it responsible? What if it tells? What if it's not right? What if it says something is open but it's not, and a truck driver makes a decision based on that? I mean, there's a lot of things that I think need to go into determining the right way of disseminating this data. But I do think more work needs to be done to evaluate it, to see if it's reliable and it tells a reliable story in different places. There's coverage issues we need to think about, and it may just be a case-by-case state basis, like, okay, yeah, I in Maryland feel like this is pretty good, but if I'm in Tennessee, I might not. So I think there's definitely a lot more evaluation that goes into that. And then also identifying a lot of states, and I know I do a lot of work with Maryland, and they're in the process of setting up a freight data platform exchange to try to understand what all data they have and what can be made available to the user community, the best way of getting that back and forth and collecting information from like truck drivers. So I think further discussions on that front are needed as well. And I'll just stop there. But there's a lot, but I think immediate next steps are like, let's do more of this. Let's explore this a little bit more and have more conversations.
And I would just add to that as well, one thing that I think I found really interesting from a lot of the knowledge synthesis that we did was a lot of the conversations about safety related to truck parking really is anecdotal. So, hopefully maybe in the future there would be a way to kind of bring that information more into this dialogue as well, and really evaluate how inadequate truck parking really is impacting heavy duty truck crashes.
I have a question from Scott.
Yeah, my question is this. I was glad to hear what validates my personal belief as someone who has a CDL and has driven over 1 million miles accident-free in my career, that truckers were indeed asking for that data on truck parking information systems to be accurate and not just tell them low, but to say specifically how many spaces are available. I'm curious, did you get any feedback, or did you approach DOTs and ask them why they're choosing to do that versus publishing the actual numbers? Is it just they're concerned about the accuracy of the systems that are now antiquated, or any feedback on that? I appreciate.
Yeah, that was not a direct question that we asked in our early initial interviews, but you know, every state has their own approach and reasons behind why they determine their truck parking information system. So, but it's definitely something I think we can also look into more in the future as well, because it was something that continually came up when we did speak with the truck drivers, that just the hesitancy of trusting truck parking information signs.
And in Maryland, the test area, they don't have a truck parking information system. In fact, you know, I think a lot of states don't. And that's something that's new to them. And so this is kind of how can we use data to gap that until the state can invest millions in a truck parking information system or whatever the cost is. So this is trying to get something in lieu of having nothing. And in terms of, you know, so I don't think there's a lot of states, right? I mean, I don't know too much about what gets disseminated from some of the states that do have some systems. I thought that they were providing information on availability, but in terms of like what Maryland has, in the past, all they had were manual counts taken from 2-ish days a year and 2 hours of those days. That's, you know, and that information was always public. So, you know, I think we're trying to get there and trying to figure out how to use information, kind of like what's low hanging fruit we can grab and put it out there.
All right. There's also a question from Andy Alden. Let me go ahead.
I actually make a comment on the last person's comment, and I believe that part of the reticence of the DOTs to give exact numbers stems from the fact that even if the detection system itself is 100% accurate, and at the time it checks, there might be, say, 2 spaces open, in the time that the truck driver that's interested in parking there travels to that site, things could change. And so there's a little bit of concern there that if you tell people the exact number of spaces, they have this expectation that when they drive in, those spaces will be available and they can park. And that could easily change in a matter of minutes. And so I think that's one of the reasons they're sort of a little bit fuzzy with the numbers sometimes.
Yeah, I encourage, if you haven't, and you look at the chat right now, there's some conversation going on about knowing hours of service and, you know, being able to predict where you might be able to park due to your hours of service limitations, and as well as the fact that the reliability or the accuracy of those parking spots that are available might be difficult without actually a person on the floor and really, you know, looking at that.
Well, and you know, I'll chime in too real quick on hours of service, and that again is something that came up in the interview process as it relates to actual ELDs, that there's maybe some potential if messaging could be shared on an ELD, the ELD is going to, you can understand better based on your hours of service left than where you would need it. I mean, if the technology of the messaging is accurate enough that it could know when to tell you when to park, there's definitely some opportunities there, I think, for future investigation on the use of that.
All right, Levi has a question or a comment.
Yeah, I was just curious, in your research, was there any question about what amenities the drivers kind of, their minimum requirement? I guess it would be, I'm going to park here if it has fencing, lighting, things like that. I mean, from a DOT standpoint, you know, trying to create additional and things like that. Obviously, everybody's budget's always constrained, so you're trying to do the best you can with the dollars that you have available. Just kind of curious if you have any information on what the desires and minimum requirements are from the community.
Yeah, so that was not a direct part of this project, but it did come out in the knowledge synthesis. So I think there are some findings in our final report on that. But I know of several research studies that have analyzed the amenity preferences. It is a little unique because different types of drivers have different preferences. For example, there's different preferences between female drivers and male drivers in some cases, and we did talk about that a little bit with some of the drivers, but again, it wasn't the key focus for this. It was more on the messaging needs.
We have a question in the chat from Eric Glenn saying, is there an opportunity in the future to bring in an option to reserve spaces? It could be based on the distance and return to space.
I think certainly it would be cool if well, let me back up a minute. Yeah, a lot of private locations and perhaps some of the state ones do offer a reservation system. And from the past Jason's Law work that we were involved in, we know that is useful when truckers can rely on having that reservation, unless there's a reliability issue in which they get stuck and they can't make use of it. So that's a whole nother discussion for another day. So I think, that is something that happens now, and going forward, being able to reserve or have spaces definitely helps truck drivers, and Scott Gernarth can weigh in on that probably way better than I can. For this work, what we were specifically trying to do was say, okay, states have this data, they're using it for lots of other different things. How can we squeeze value out of it to help them understand truck parking, supply and demand, and to help tell a story about truck parking that they can engage people on, and if it was reliable enough to share that information with drivers. To try to add a reservation system on top of that would be probably another effort and involve more ITS. But I think my hope is that this type of work continues to open up this platforms of ideas, and that we can grow into things like that. So Scott, I see your hand up.
Sure, I'll just really briefly hit on the highlights there, because you're right, I could go on forever with that. But just very briefly, the company I work for, we actually operate reservable, secure truck parking facilities, and we've expanded to the 3rd facility in Detroit, Michigan now from the original one. So if there's no doubt at all, there's a demand in a big way, especially when the reservation is for a secure facility. I know truckers do have great concerns when all you're doing is charging them for the same space, that you would have gotten for free the day before. That kind of rubs people the wrong way sometimes. But and then Nicole brought up a great point. It is, when you're dealing with an industry where truckers don't control their schedule, where shippers and receivers can detain them for no good reason at all, totally unforeseen, that makes it difficult. But that being said, I don't have any friends I know of the many people I know that are truckers to this day who have made a reservation they couldn't use. They'll usually just wait until they know, yep, I'm definitely going to be out of here, and I'll go ahead and make that reservation now, because it does help tremendously. It eases your stress enormously when you know you've got that spot, because hopefully you're not going to become the next Jason Rivenberg because you've got a safe, legal place to park.
All right, we are almost out of time, so I'm going to jump in and first say thank you guys very much for the entire conversation, for presenting your research, and for everything else. If you haven't seen, there is a lot of comments in the chat, and the great thing is that this actual webinar will be available on YouTube. There'll be a link that's going to go up on our website, as well as we can email that out to you, all of the people who have actually attended this webinar. And in addition, registration is open for our next webinar. The next webinar we're going to have is going to discuss the usage of 5G technologies and video analytics through edge computing to enable safety critical communications between pedestrians and vehicles in common intersection scenarios. That webinar is scheduled for February 16th at 2 o'clock. And you can register for that on our webpage. I'm also going to send you out the registration link via the chat as well. And you can also, again, at our website, which I will send out right now, you can look at upcoming webinars, and you can also see the archive of all past webinars that we have hosted. And that's coming through the chat box right now as well. So thank you very much, and hopefully we'll see you at the next safety webinar.